Hey, Dr. Ray here, founder of the Learning Liaisons, and welcome. Welcome to our Wednesday evening math sessions featuring our math specialist and your math specialist, Amy Sink. In the next hour, Amy has put together a sample set of approximately 10 practice questions that run the gamut from kindergarten levels all the way through 12th grade high school math. Now, I know you are attending here, watching this, and you're like, well, I'm doing elementary in Texas, or I'm doing elementary in Praxis, or I'm doing high school math in Florida, or middle school math in Texas. And what's going on here, right? So we're doing these sessions to help you guys out and provide you with different ways to look at problems and to build that confidence. Because here at the Learning Liaisons, one of our major objectives is to clear up the testing confusion, give you the support you deserve in order to nail your exam and be done with it. So our focus is on math. Now, are we going to be just focusing on high school math the whole hour or elementary? No. We've got a mixture here. Now, Amy is going to go through a bunch of problems. You're going to have the opportunity to download those as a PDF. So when Amy starts, just pay attention to the screen. We're going to have a message there for you so you can download the PDF in case we don't get to all the problems or want to practice on your own. She's going to do her best to go across all different grade levels. If you have a question, you feel free to ask Amy your question as well. We're teachers here too, so we can multitask. Our job is to make sure that we give you what you need to be successful. But if you're like, dang it, I didn't have any questions this week, don't worry, we'll be here next Wednesday night as well. So bring those questions with you if you want, and you can ask Amy away. Because here at the Learning Liaisons, we pride ourselves in providing you guys the support you need to pass your exam. So whether you're our Florida teachers here with our FTCE exams, our national exam Praxis peeps, big shout out to you guys out there too, and especially our newcomers to the Learning Liaisons brand, TExES Prep. So whether you're elementary, middle school, and high school, we've got your back. So sit back, relax, grab your popcorn, get ready to learn some math, and stay tuned for the end because I'm going to jump back on to close this out. And I got a special surprise for you guys who really want to get the real deal prep and get everything you need to be successful and practice, clear up that confusion, and pass your certification exam on the next attempt. So, welcome to the Learning Liaisons community. Always remember, it's when you pass, not if you pass. So without further ado, let's turn it over to the reason why you're here, Amy. You with us, Amy? Let's get going.
Hey everyone, surprise, surprise. It's not Amy today, it's Pryia, and happy Wednesday. So today I've got some questions for you guys. I've made it a little bit more difficult than I normally do. So let's go ahead, let's jump in, and let's get started. Question 1, as you can see, it's an algebra, middle and high school level. So algebra 1, definitely. So let's go ahead and read the problem, and let's go ahead and see what we need. This year, a salesman sold a total of $6,000 worth of vacuums by going door to door. This represents a 20% increase from the year before. What is the value of his sales last year? So the key there is we want to know his sales from last year. But what's the information from the problem that we need? We definitely need the total of $60,000, and we need to know that he increased by 20%. So from that, what are we going to do? What do we need to do? It sounds like we need an equation. And we're going to make this together. So what our equation is going to need is that 20% and the 60%, but we also need to have a value x. We need to solve for something because we're missing the piece of information that we need. So let's get ahead and do x, and x is going to represent the total of last year's sales. Right, now that we have that, let's go ahead and figure out what's going on with this 20% increase. So remember, we increased our sales from last year by 20%. So we hit our goal of last year, which was 100% of last year's sales, added the 20%, and we'll get a total of 120% for this year's goal of what we did? Well, we can't do anything as a percentage, we'll need a decimal. So let's go ahead and turn this into a decimal. There's a couple ways to do this. Percent, you divide by 100, so 120 divided by 100, we'll get 1.2. Or you have 120, put the decimal where it belongs and move it to the left 2 places. Get the same thing. All right, so we have 120%, which we converted to 1.2. And now let's put that into our decimal form. So we have our sale increase times what we're looking for, which is equal to $60,000. Right? If we solve for x, we should have an answer. Divide both sides by 1.2, because right now 1.2 and x are being multiplied. They're stuck next to each other. So we do the opposite operation, which is division. Divide out, x is equal to what? $50,000. So the value of last year's sale, $50,000. Not too bad. Word problems never did anything to you. I tell you guys that all the time. Don't discriminate. Let's try problem number 2. Okay, so it's a simple couple words. It's not asking us much. The answers are simple. So let's figure out what's going on. Before I start, let's mention that it's an algebra, middle and high school problem, all right? So the question asks, what is the reciprocal of -3? Well, if you know what a reciprocal is, it means to take the inverse, take the opposite of what's going on. So here we have a whole number, but let's turn it into a fraction. Any number by itself can be put over the number 1. Now it's the lovely fraction that we need to do an easy reciprocal. We'll take the opposite sign. So we have a negative, we're going to go to a positive, and then we're going to take the fraction and flip it, which means the bottom moves to the top and the top moves to the bottom. That's it. That's all there is to a reciprocal. So we're going to take the opposite sign and flip the fraction. It's not that bad. So if it was a positive, it would end up being a negative. And if we didn't have a fraction to begin with, we turn it into a fraction and we do what we need to. All right. Here's one of those questions I'm pretty sure if you read it to yourself aloud, you're going to start hating me a little bit. But that's okay. That's what I'm here for. I'm here to challenge you. So let's get through question 3. Before we begin, it's an algebra problem, and it's for middle and high school levels. So Chris is 3 times older than Anna. Brandon is 2 years older than Anna. In 6 years, the sum of Anna's and Brandon's age will be the same as Chris's age. How old is Chris? All right, well, we have to figure out how old Chris is. Well, we have a bunch of information to start off with. They tell us that Chris is 3 times older than Anna. What else do we know? We know that Brandon is 2 years older than Anna. And in 6 years, the sum of Anna and Brandon's age will be the same as Chris's age. So we have to make a couple equations. Doesn't seem too bad. If you're freaking out, don't. We're going to get through it together. So let's start with the green highlight. Chris is 3 years older, 3 times older than Anna. So 3 times Anna's age is Chris's age. So remember, is our equal sign. So if Chris, let's use C for Chris, let's kind of represent all of them by different letters. So C for Chris, B for Brandon, and A for Anna. If Chris is 3 times older than Anna, whatever Anna's age is, he or she is 3 times older. The only way to represent that is to be 3a. 3 times Anna's age is Chris's age. Let's figure out what's going on with the blue highlighted. Brandon is 2 years older than Anna. So Brandon is, and then how do we do this? 2 years older than. So I'm 31. If someone was 2 years older than me, I would add 2 to my age. So let's do 2 plus whatever Anna's age is. Doesn't seem so bad. And the last one, this is the doozy. In 6 years, the sum of Anna's and Brandon's age will be the same as Chris's age. In 6 years, the sum. So now they're telling us the sum means to add everything, right? So now we're adding everything. We know we have to do an addition problem. We're going to do an addition problem, but not forget that we're 6 years from now. So whatever my age is now, we have to add 6 because it's 6 years in the future. All right? So we have to figure out Anna's age, Brandon's age, and they say that it will be the same as Chris's age. So the sum of Anna's age and the sum of Brandon's age is the same as Chris's age in 6 years. So how would I represent that? Anna's age plus the 6 years plus Brandon's age plus the 6 years is all equal to Chris's age plus the 6 years. All right, I've got 3 equations. I have no more information. And the question is asking, how old is Chris? Well, what are we going to do with all this information? Well, I see a pretty quick solution. I know that C is equal to 3a and B is equal to 2a. Why is that important to me? That's important to me because if I try to solve this red equation down here, I have too many variables. I have an A, a B, and a C, and all of them are unaccounted for. I have to find a way to solve for one variable at a time without mixing up any of the. So the best thing I can do is every time I see a C, I think C goes this way, a C, I'm going to put 3a. And every time I see the letter B, I'm going to put 2 plus a. All right? Let's do that together. So remember, every time I see the letter C, I'm going to put a 3a, and every time I see the letter B, I'm going to put 2a. So let's start. A plus 6 plus, okay, here's my B. I'm going to put 2 plus a, and then I'm going to put the original plus 6 is equal to, and I have the letter C, so the letter C is 3a, and put the original plus 6. Okay, we're going to do PEMDAS and we're going to solve. Remember, I write PEMDAS a little differently from everybody else. I like, please excuse my dear Aunt Sally. So which one do we see first? Multiplication or division, addition or subtraction? Remember, moving from the left all the way to the right. So let's start. I'm going to start with my parentheses. Is there anything to do in the set of parentheses that I have? Well, I can do something small over here. There's nothing to do here, so I'm just going to write it as it is. A plus 6. Now I'm going to add the stuff together inside the next set of parentheses that can be combined. I have a 2 and a 6. 2 plus 6 is 8. And I can't add anything else together, and I'm going to bring the a down. There's nothing left to do in the last set of parentheses, so I'm going to keep it 3a plus 6. Okay, it doesn't seem scary. Fine. Remember, we're going to combine all like terms, and then we're going to start moving things from one side to the other. All right, let's see. We have 6 plus 8, which is going to give us a lovely 14. We have one A here and another A here. So we'll have 2A and keep everything else the same. All right, we're almost there. We want to put all our A's together and we want to put all our numbers together. Hope, I'm going to come back to you. Let me finish the problem and then we will answer together. So let's move all the A's together and then we'll move all the numbers together. So I'm going to move 2A because it's the smaller of them. You can move them in any direction that you would like. To save space, I'm going to do 2 at a time and I'm going to move the 6. So I'm going to do 14 minus 6, which is going to give me 8. Oh, I ran off the page. It's going to give me 8. And then I'm going to have 3 minus 2, which is 1, or the same as A. Question, is this my answer? No, 1, it's not an answer choice. And 2, what did we answer? We answered A, which represents Anna. So that's not Chris's age. They asked how old Chris was. So if we look back at all the lovely equations that we have, remember we said Chris's age is 3 times than Anna's age. So Chris's age is 3 times Anna's age. Well, Anna's age is 8. So we'll have 6, not 6, C is equal to 3 times 8. 3 times 8 is 24. Winner, winner, chicken dinner. Guess what? 24 is an answer choice, and it is our answer choice. All right? I know, it seems like a doozy. It's one of those questions that you just have to take your time on, right? Take it step by step. Write out, take the words and turn them into numbers. The equations that you can form on your own, the better it is for you because you can get through this. All you have to do is take your time. Great. I'm going to focus my attention on the chat box. I saw that Hope asked a question, so let's go ahead and help Hope out for a little bit. She's a little confused about question number 2. She thought that the reciprocal value made the value of the fraction equal to 1. So let's go back to number 2. And she said that she thought it would make it negative 1/3. Well, yes, you flip the fraction, but it's not just flipping the fraction and taking the, like flipping the fraction in the sense, I can't come up with another word of flipping right now. So it's not just flipping the fraction. Reciprocals are taking the opposite sign of what you already start with. So if I had to give an example, I would say, let's start with, what's a bad example? 7/4. It's an improper fraction. We're not worried about the numbers. What we're worried about is figuring out how to take the reciprocal. So it says to do the opposite sign. So right now my fraction is positive. I'll need to make my reciprocal negative. And then what I'm going to do is take my denominator and put it in my numerator, take my numerator and put it in the denominator. So I'll have 4/7. That would be the reciprocal of 7/4. So it's not just taking the fraction and flipping it, moving the denominator to the numerator and the numerator to the denominator. It's also taking the opposite sign. So if it's positive, it becomes a negative, and if it's negative, it becomes a positive. Great question, Hope. All right, so hopefully number 3 didn't scare you guys. I've got a couple of problems today. I'm on a kind of word problem kind of mood. All right, let's try something new. This question is focused on algebra, not middle school this time, just high school. And if you read the problem, you'll see that it's definitely a high school problem, but it's nothing to scare you. So we're asked to find the vertical asymptote or asymptotes of the function. Sometimes it can have one, sometimes it can have more. So we have to figure out how we're going to do this. Well, if you don't know what an asymptote is, let's start there. So an asymptote is a line. Oops, okay, I apologize. My handwriting's gonna just be all over the place today. It's a line that the graph of a function approaches but never touches. So if you were to take this and put it in your graphing calculator, let's say that it gave you this line that looked like this. Well, this would be an asymptote because it will get as close, not supposed to curve, but it will get as close as it can to that x, but it will never touch it, right? So we want to keep that in mind when we're doing these. So the quick way, without having to graph and all that other stuff, because, I'm looking at this and I'm going, what are they thinking? Okay, I've got I've got a quotient, I've got a fraction, I've got squares, I've got regular x's. I don't know what's going on. So let's try to do this with some speed, because 90% of the time we're being timed on anything that we're doing, and let's try to do it as accurately as possible. So here is my quick tip to you. You're going to take the denominator, and then you're going to set it equal to 0. And you're going to solve. All right, so let's do that together. We have x squared minus 8x plus 15 is equal to 0. Well, I'm not going to move stuff and do all that and solve for x by itself. I have an x squared. I'm looking at this and going, well, you know what? It may not seem that bad if I factor. In order to factor, I need to know a few things. I need to figure out the the factors of 15 that will add or subtract to make negative 8. So what times what will add or subtract to make negative 8, but multiply to make 15. So let's write some factors of 15. I have 1 and 15. No matter how I try this, I don't know about you, but I cannot add or subtract those numbers to make a negative 8. So let's try something else. Well, 2 doesn't work. Well, 3 would be 3 and 5. Well, 3 times 5 is 15, but 3 plus 5 is positive 8. I don't want a positive number, I want a negative number. So if I make both of them negative, I know that negative 3 times negative 5 is positive 15, which is what I need. And then I know that negative 3 minus 5 is equal to negative 8. All right, those are the two numbers I need. So in order to factor, you start with your x's in the front, and then you put your numbers. So now I have negative 3 and negative 5. I'm going to give us some space by erasing all of this. And then let's finish solving. So now that I'm looking at this is not my answer. I still have to do a little bit more to be where I need for my answer. So I cannot look at this and say, oh, A must be the answer. A is not the answer. We have to keep solving. Set both of those x's equal to 0. Once you solve for x on both sides, now you'll have what your answer should be. So x is going to be 3, and x is also going to be 5. Those are the answers that we're looking for. Winner, winner, chicken dinner. So our vertical axis here, 3 and 5. So the graph will go as close to 3 and as close to 5 as possible, but it will not cross or touch those two numbers. All right, here we go. We have another question. It seems like a short question, but let's figure out what's going on. Before we start, this is statistics. It can be found in elementary, middle, or high school. This is kind of one of those questions where it can be across the board. What is the probability of flipping a coin and landing on heads each time? So one of the key words in here is probability, and then we want to know what we need to do with it. We're flipping the coin and landing on heads each time. I forgot to tell you how many times we're flipping the coin. So what is the probability of flipping a coin 3 times and landing on heads each time? Promise. I'll check that next time. So the probability that we're looking for is flipping one coin 3 times. Okay, well, if I think about a coin, the first one that comes to mind is a quarter. It doesn't have to be a quarter, it can be anything. But if I'm thinking of a quarter, there is normally a heads and there's a tails. And normally on the tails, there's like this eagle. Okay, so we have a heads and a tails. There's nothing else that we could possibly get from that quarter. No matter how we flip it, it can only be one or the other. So when we're doing something like this, we ask ourselves, well, how many times are we flipping the coin? For sakes of time, I'm going to condense my words, maybe make it a little grammatically incorrect, but that's okay. We're all on the same page. So how many times are we flipping the coin? Well, the answer is 3 times. So if we're flipping it 3 times, we need what? We need 3 fractions. So let's start with our 3 fractions. 1 fraction multiplied by the second fraction multiplied by the third fraction to give us our answer fraction. So we have our 3 fractions. We know that the numerators are always going to be our part, right? Our numerators are going to be the part, and the denominator is the whole. This is what we've been told our whole life. Nothing has changed. So now we ask ourselves, what is the part? What is our outcome? What do we want? We want to land on heads. Heads and heads. Okay, well, on any coin, if this is my heads, there's my tails. How many heads do I have on one coin? I only have 1. So I know it's always possible to land on at least, well, there's only 1 head. And how many sides of the coin do I have in total? Well, here's my tails, here's my heads. If I count the amount of sides that I have, I only have 2 sides. So no matter how you look at this, you can only have 2 outcomes, and you want one of those 2 outcomes. I want a head out of a head and tail. I want a head out of a head and tail. There's no other way to do it. So let's go ahead and figure out how to solve. Well, 1 times 1 is 1 times 1 is 1. That was pretty easy. Now make sure you're multiplying because this can get a little tricky. 2 times 2 is 4, and we're not adding, we're multiplying. 4 times 2 is 8. If you added and got 1/6, you're working a little too quickly and not paying attention. Our answer that we're looking for is 1/8. We have a 1/8 chance of flipping the coin 3 times and landing on heads each time. All right, here's another problem, problem number 6. Well, before we start, let's talk about what it is. It's a geometry problem, middle and high school levels, all right? Doesn't seem so bad. It's a word problem. I know most of you hate word problems. You discriminate against them because they are words in math, but we don't hate them, okay? So let's do it together. It says, the key on a map indicates for 1/4 inch, it's 1 mile. Okay? If Bobby measures 3/4 inches, 3 3/4 inches on the map, what is the actual mileage? Well, we have to figure out what's going on. We know that we have 1/4 inch is a mile. Most of you are screaming because there's like fractions and whole numbers, and you're like, I don't like fractions. Okay, well, these fractions aren't too hard to put in decimal form. So let's go ahead and redo the 1/4, and let's make it into a decimal. 1/4 is a quarter, which is 0.25. So now we know that 0.25 inches is equal to a mile. Well, it says that Bobby went and measured 3 3/4. Let's go ahead and turn that into a decimal as well. Well, 3 is our whole number, and 3/4 is what we need to turn into a decimal. So I have 3/4 or 3/4, which is going to be 0.75. Remember, that's inches. So we have decimals, we have miles and inches, and what are they asking us for? Mileage, for miles. Sounds like a proportion. How do I know that it's a proportion? Well, I have one full set of information, which is here, and I have half of the other piece. How do I know I have half of the other piece? I have an inch and a mile to start with. I have an inch, but I'm missing the mile. So I'm going to go ahead and set up a proportion and solve that way. A proportion is going to be two fractions that are equal to each other. On the first fraction, we're going to put the full set of information in. So I'm going to start with 0.25 inches on the top. So I'm going to put my inch on the top and my miles on the bottom. It does not matter how you put in the first set of information. What matters is how you put in the second set of information. So I'm going to start with my 1/4 inches on top and my 1 mile on the bottom. I like to write my inches and miles because when I'm taking a test and I'm writing all these numbers down as quickly as possible to get through that time, I don't have a doubt in my mind what those numbers represent. So it takes 2 seconds to just write those letters out, but it takes you a couple minutes to figure out what went wrong. Because remember, now it matters how I put in that next set of information. So let's go ahead and put in the other fraction. Well, I can't put 3.75 at the bottom because 3.75 is inches, it's not miles. So I have to put 3.75 at the top because it's inches, and remember, we're solving for our miles. How do we solve the problem? We're going to cross multiply. 0.25 times x, 0.25x, and then 3.75 times 1. 3.75. All right, we're almost there. What's our last step in order to solve for x? Well, 0.5 and x are being mushed up next to each other. So I'm going to do the opposite operation. When they're mushed up, they're being multiplied. I'm going to separate them by dividing. Remember, nobody likes their x, and we're divorcing them at this point. We're getting away. All right, when I divide 3.75 by 0.25, what is the lovely answer that you guys are getting on your calculator? Or if you're doing math by hand, you should get 15, and 15 is the miles, so the answer is 15 miles. See, word problems don't seem that bad. You just have to take it step by step. Okay, before we start the problem, let me begin by saying I really couldn't tell you what I was thinking when I made these answer choices because I was looking at them right before the PowerPoint, right before we started, and I don't have a correct answer in mind. And you know what happens? Sometimes I get so caught up creating all of these incorrect answers that I forget the correct answer. And that's exactly what happened today. So let's go ahead and not worry about the answer choices. And we don't need answer choices because we could totally answer this without someone telling us how to do it. We're going to do this together and we're going to be great at it. All right. So let's start off with figuring out what the question is asking us. All they're asking us to do is expand the expression that we were given. And this is the lovely expression. Well, let's go ahead and start. It's an algebra problem. I forgot to mention that. I was doing so good. It's an algebra problem. It's for middle and high school. So first off, we're looking at this problem, and it's saying that whatever's in the parentheses is cubed. It's to the third power. What does that mean? What does that really mean? Well, it does not mean just cube everything inside the parentheses. If you had a squared, what would you do? So it's similar to the square, but it's with three of them. So what this problem is actually telling us to do is it's saying a minus 3b times a minus 3b times a minus 3b. So let's talk about it. If I had 4 cubed, how would you do that? 4 times 4 times 4, right? So it's the same thing. It's the parentheses, what the parentheses is, times itself 3 times. All right? So let's go ahead and solve. Let's start with the first two, and then we'll work our way to the third one. So right now I have a minus 3b multiplied by a minus 3b. All right, well, a lot of you know this as FOIL, first, outer, inner, last. I try not to remember little things like that. I try to remember a little bit more of how to do. So if FOIL helps, completely okay. I'm going to show you the way that I like to do it. I like to take the A, the first term, and give it to the first term and the last term of the other set of parentheses. So if I do that, I'll have A times A, which is A squared, and then I'll have A times negative 3B. Well, A times negative 3B is just going to be all of them mushed up together. So we're going to have negative 3AB. Now I'm going to do the second term. The second term goes to the first and the last. It's the same as FOIL, but if you remember that you have to give the first to all and the second to all that's in the next set of parentheses, you'll never mess this up. So negative 3b times a is the same thing that we just did. So it's negative 3ab. And then we're going to multiply. Negative 3b times negative 3b. Okay, well, negative 3 times negative 3 is a positive 9. B times b is b squared. All right, let's condense this, and then we have to multiply by that last a minus 3b. So what can we put together? What can we combine here? Well, the only things that are like terms will be the negative 3ab and the negative 3ab. So we're going to put those together. So we're going to have a squared minus 3ab minus 3ab. So negative 3 minus 3 more is negative 6 ab. Remember, we're adding and subtracting, so now they're staying the same, plus 9b squared. All right, remember, we have one more a minus 3b to do. So remember I talked about not using FOIL, just remembering the concept? That's going to apply here. So now I'm going to write it in front so it looks the same. So I'm going to take my first term and multiply it by everything in my parentheses. So a times a squared is a cubed, or a to the third power. A times negative 6 ab is going to be negative 6. A times a is a squared, keep the b. And then the last one is going to be a times 9b squared. So 9 ab squared. Okay, now remember we're doing the same thing. So now we're going to take the second term and multiply it by everything on the other side. Negative 3b times a squared, negative 3a squared b. I like to keep my a's first, then my b's. It makes it easier to see things when I'm coming down to the end. Then we're going to have negative 3b multiplied by negative 6ab. So negative 3 times negative 6 is negative 18. A times no other a is going to give us a by itself, and b times b is going to give us b squared. All right, last term. Negative 3b times 9b squared. Okay, so negative times a positive is going to be a negative. 3 times 9 is going to give us 27. And b times b is going to give us b squared. Okay, we're almost there. All we have to do is look at our like terms and combine them. All right, here we go. Let's move it up a little bit. Ready? And go. Is there any other a cubed? Nope. So a cubed stays. Now I'm going to, are there any a squared b's? Yes, there is. They're right there. So both of those a squared b's, we're going to subtract them. So negative 6 minus 3, negative 9, a squared b. Well, is there any a b squares? Yes, there are. There's one here and one over there. So I'm going to subtract again. Negative 18 plus 9. I'm going to have negative 9 a b squared. And are there any more b squares? No. And I'm going to leave negative 27 b squared at the bottom. And guess what our answer is? Exactly that. the expanded version of what we started with, a minus 3b cubed. Two negatives do make a positive in multiplication and division. Did I by chance mess up? Because it could be possible. I'm okay if I messed up. I'm going to check my work really quick. Positive, positive, positive. Positive, negative, negative. Negative, positive, negative. Negative, negative, positive. Okay, hold on. You are correct. I messed up on my negative and my positive. I'm going to correct that with blue. So the negative 3b times negative 6, negative and negative gives us a positive number. Into 3b. Okay, so then that will fix that number there. When we redo our math, let's see, it'll be 18 plus 9, so now a whole nother number. This is why keeping track of your numbers are very important. I apologize. Okay, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 27. Okay. So negative 27, positive 27, positive 27. Okay, let me just make sure this is correct. So then negative, negative, positive, and positive, and negative, and positive, and negative 3b, negative, and then positive, and then negative. I'm getting a negative for the 27b cubed with b cubed. I say one thing, I write another. I apologize. What about 3b times 9b squared? 3b times 9b squared. So the negative 3 times the positive 9, because we made sure that one was positive. The negative times the positive will give us a negative number, and the b times b squared will give us b cubed. I said cubed, I wrote squared. I do greatly apologize for that. Okay, I'm gonna look at it one more time. I'm not here to confuse you. This is what naturally happens when you're doing this math. As you can see, I've got scribbles everywhere. I'm saying one thing, I'm writing something else. This happens to you guys when you're on your test. It doesn't mean you don't know how to do your math. It's just we're trying to do math so quickly that it's starting to get a little confused. So I'm going to look at it one last time really quick. I'm going to keep quiet. I promise. It's going to take me less than a minute. Okay, so I looked back at it. All the blues are the corrected stuff, I promise. Our answer is going to be a cubed, a to the third power, minus 9a squared b plus 27ab squared minus 27b cubed. I really hope we're right this time. That's the thing about doing problems that are so long. You really do start taking over. Like your mind starts telling you one thing, your hands are writing something else. It really can be a little bit of a disaster. And I do greatly appreciate everyone working with me and letting me know. I'm always up to know when I'm wrong. All right, let's try some calculus. It's quick, it's easy, it's simple, and it'll be the last problem that we go over for the night. I'm not brain dead, but after that last problem, I'm feeling a little weak in the knees, even though I'm sitting in my chair. So what we're going to do is the derivative of the lovely function that we have. Because it's a sum, we're going to take the derivative of each term individually. So a really nice way to write that would just be the derivative of 6x cubed plus the derivative of negative 9x plus the derivative of 4. So what we're doing is keeping our numerator, keeping our whole numbers. So the constant in the front, 6 times, now we're taking the derivative of this. So a quick way to remember derivatives is you take the exponent, you make it into a whole number, and you lessen it by 1. So I'll get 6 times 3x squared. And I'm going to do the same for negative 9. So I'm going to add the derivative of what I'm going to get. I keep my negative 9. Remember, I'm just keeping these in parentheses, keep them separate right now. I'm going to take my my exponent and put it in the front. So I'm going to multiply it by the other number. So I'm going to multiply it by 1. And I'm going to lessen that exponent by 1 as well. Well, 1 minus 1 is 0, so the x in this case is going to go away. Cool thing here is we get nothing. We have no x's, so we have nothing to multiply by. So now we have to just figure out kind of what's going on with the other stuff over here. So if we look at the first derivative that we took of 6x cubed, 6 times 3 is 18. There's no positives or negatives. That makes it a little easier. And we're going to keep the x squared. And then the second derivative that we took off to the negative 9x, not taking the actual second derivative, is going to be negative 9 times 1, which is negative 9. Okay, well, that's it. That's all there is to this one. Let's go ahead and find our answer choice. So our answer choice is going to be C. Those of you who are a little confused as to how the notation looks, when you take the first derivative of something, you use a lovely apostrophe. That indicates the first derivative. When you take the second derivative, you use 2 parentheses. So on and so forth, right? So that makes it a little bit easier to understand how many they're also asking you for by just looking at your answer choices. So let's just say they asked, well, the question can remain the same, find the derivative of the function, but if they had 2 apostrophes out here, we would have to take the derivative again. Yes, that's possible. You can take the second derivative. If we took the second derivative, it would be the same thing that we did the first time. Remember, we're going to take the exponent and move it to the front. So 18 times 2. Keep your x and lessen your exponent by 1. So it's just going to be an x. 18 times 2 is actually 36. 36x. Negative 9 doesn't have an x, so there's nothing else for it. The second derivative, just in case you were wondering, is 36x. It's not the answer that we're looking for, let me be clear, but it is just there to be there. All right, guys, before I leave, I just erased it and put it back on. I apologize. Before I leave, let's have a quick little chat about some stuff that you need to know. So first off, thank you, every single one of you, for showing up this evening. And thank you for correcting me when I make a mistake. We're all humans and accidents happen, mistakes happen, right? Especially in math. That's one of the reasons we're all here. We're learning math together. And just some extra stuff that you may need to know. There are one-on-one, one-to-one sessions here offered through the Learning Liaison. And all you need to do is go to www.thelearningliaisons.com and you'll look for the online tutoring option, right? So you'll go to the tabs at the top, and then don't forget there's a discount code. I'm not Miss Sync, but Sync35. That's what you need to remember. Sync35 is going to give you some money off, which we all love a great discount. All right. So I really hope you have a great evening, and thank you again. It's off of all of the courses. Yes, not for the tutoring. Let's be clear. Sync35 is off of the courses, not the tutorings. All right. Have a great day. I'll see you next time.
All right, so wasn't that an amazing session? Now, I know, depending on what exam you have to take, you're like, man, that was great, but she didn't address everything I needed. She focused on all different questions that I just need elementary, or I just need middle school, I just need high school. Don't worry. Since you're still with us, I've got a special surprise for you. If you use the coupon code, all capital letters, SINK35, that's SINK 35. That will take off 35% off any of our prep courses on our website at the Learning Liaisons. Doesn't have to just be math. It could be anything that you need that we offer. And this is going to be an ongoing deal for you guys who attend these live sessions, because these are great. I'm sure Amy opened your eyes to some new concepts, some new ways to tackle problems, building that confidence. But this is just a smidget of your exam, the concepts on your test. So if you want the comprehensive view with the practice with Amy, with the practice test, with the lessons and the content review, we've got your back on our video boot camps, which all of them feature Amy Sink, your math specialist. So if you want to take advantage of that, the code is SINK35. You can use that at checkout on the learningliaisons.com website. And all that information is on our website as well, and on the bottom of the screen in this video. So we are here to help you. Once again, always remember, it's when you pass, not if you pass. Thank you for joining us again today, and hopefully we'll see you next week too. Talk to you soon.